This is part 5 of the series Applications of Differentiation, and we're continuing with finding extrema on a closed interval. So, as we have in the past, we're going to find the extrema of this function, 2x minus 3x to the 2/3 on the closed interval -1 to 3. So, we're going to take the first derivative. So, let's go ahead and f prime of x equals the derivative of 2x is just 2, derivative of this minus 3 times, pull down the exponent, 2/3 x, subtract 1 from the exponent, -1/3. This simplified gives us 2 minus, well, this 3 cancels out that 3, and we have 2 over x to the 1/3. This 1/3, x to the -1/3 has to go in the denominator. So now we have to simplify this a little bit so that we can solve. So this times this is 2x to the 1/3 minus this times this minus 2 over x to the 1/3, and that's equal to 0 because we have to solve, because remember that the critical numbers of this function are where the derivative is either 0 or undefined, and so we're going to say this is 2 equals 2x to the 1/3 minus 2. Add the 2 to both sides. 2 equals 2x to the 1/3. Divide by 2. 1 equals x to the 1/3. And take the cube root of both sides, so x equals 1. Now, this was important to do because we also see that at x equals 0, this first derivative function is undefined. So we have a second critical number at 0. Remember, critical numbers exist where the first derivative is either 0 or undefined. So x is 1 and 0. So now we have our values. What we're going to do is we're going to try and find the values of this function at the endpoints. So we need f of -1. We need f at 0, f at 1, and f at the other endpoint, f at 3. I like to just do them in order. And so we'll go ahead and plug these into our calculator. So f of -1 is -5. F of 0 is 0. F of 1 is -1. And f of 3 is a little bit more complicated, but it rounds out to about 0.24 negative. So we can see that we have a minimum here and we have a maximum here. So our minimum is at -1, -5, and we have a maximum at 0, 0. And that's our maximum. And so once again, at -1, which is one of our endpoints, we have an extreme value. So it's very important to check your endpoints. So there's our minimum, there's our maximum. Let's go ahead and work another problem. In this expression, we have 2 sine x minus cos 2x on the interval 0 to 2 pi. Now, please try to avoid the temptation to panic anytime you see a trigonometric function. They're just derivatives, just like everything else. We have to learn the pattern before we can do them. So let's go ahead and derive this. So f prime of x is, pull the 2 out, derivative of sine is cosine, minus derivative of cosine is negative sine, and this is going to be the chain rule, so the derivative of the whole thing with the inside piece intact times the derivative of the inside, and the derivative of the inside is just 2. And so we'll simplify this a little bit. So we have 2 cos x plus 2 sine 2x. And now we want to set this equal to 0 and solve. So in order to solve this, we can see here that we have the double angle sine in here. So we're going to have to expand that out because we're going to have difficulty solving this expression for 0 otherwise. So 2 cos x plus 2 times sine double angle is 2 sine x cos x. So this gives us 2 cos x plus 4 sine x cos x, and this is all equal to 0, by the way. And we're going to factor out a cosine here. Actually, we can factor out a 2 cosine. So 0 equals 2 cos x, which leaves this divided by 2 cosine is 1, plus, and this divided by 2 cosine is 2 sine x. Now we can solve this. We can say 2 cos x equals 0, therefore x has to be equal to pi over 2 and 3 pi over 2. If you're wondering where I got this, we'll just simply do a quick XY coordinate grid. Remember that with an angle here, sine is the y, cosine is the x. So what makes the x 0? It's when the angle is vertical and vertical. This is pi over 2, this is pi, this is 3 pi. Over 2. Nice 2. So, pi over 2 and 3 pi over 2 makes cosine 0. So now, this one. So 1 plus 2 sine x equals 0. Simplifying this, we have 2 sine x equals negative 1. Sine x equals negative 1 half. And sine x is going to be, sine is negative here and here. So that's going to be, and 1 half is going to be at pi over 6. So this is positive, sine is negative here. So it's going to be negative at 7 pi over 6, and it's going to be negative down here, which is 11 pi over 6. And so there are our test values. And so we're going to have 6 now. We're going to test at 0, pi over 2, 7 pi over 6, 3 pi over 2, and 11 pi over 6. So we need f of 0, f of pi over 2, f of 3, let's do 7 pi over 6, then f of 3 pi over 2, f of 11 pi over 2, that's 11 pi over 6, and f of 2 pi. And so we get f of 0 is -1, f of pi over 2 is 3, f of 7 pi over 6 is -3/2, f of 3 pi over 2 is -1, and f of 11 pi over 6 is -3/2, and f of 2 pi is -1. So we can see that we have a maximum value at 3, so this is our max, and we have minimums at this point and this point. So there's a min, and there's a min. And so at pi over 2, 3 is a max. At 7 pi over 6 and -3/2 is a min, and at 11 pi over 6 -3/2 is another min. Okay, I hope that helped. So let's go ahead and move on to another section.